Welcome back. In this video, we will discuss the Amazon Route 53 service. DNS resolution is the process of translating an internal name to the corresponding IP address. The DNS protocol stands for Domain Name System, and it functions like a phone book where internet names are replaced for the IP addresses of the corresponding machines. Amazon Route 53 gives you the ability to register a domain name, such as yourcompany.com, and have the service handle the names and hosts related to that domain. Route 53 is highly available, scalable, fully compliant with IPv4 and IPv6 address. Amazon Route 53 supports several types of routing policies. They determine how it responds to name resolution queries. Simple routing lets you configure standard DNS records. With simple routing, you typically route traffic to a single resource, for example, a web server for your website. With weighted routing, you assign weights to resource record sets to specify the frequency with which different responses are served. You might want to use this capability to do A/B testing, also known as blue-green deployment. With a blue-green deployment, you send a small portion of traffic to a server where you made a software change in order to verify that it's all working. For example, you might send 99% of the traffic to a system A and 1% of the traffic to system B that actually have some small modifications implemented before rolling it into production. You can use latency-based routing when you want the response to arrive in the fastest way possible. Route 53 determines the fastest way to deliver a response. This does not always mean that the shortest path will be used, especially if that shortest path is saturated and slow. Geolocation routing lets you choose the resources that serve your traffic based on the geographic location of your users. Geolocation routing determines where the request has originated from in terms of geographic location, and it responds with the address of the closest point of access to your service. When you use geolocation routing, you can localize your content and present some or all of your website in the language of the geographic location of your users. You can also use geolocation routing to restrict distribution of content to only the geographic locations where you have distribution rights. Failover routing, or DNS failover, can be used to help detect an outage of your website and redirect users to an alternate location where your application is operating properly. Failover routing requires a health check to be configured. If the health check fails, the secondary address becomes and gets distributed. You can also combine any of the other routing options into a multi-value response. Here we see an example of multi-region deployment with geolocation. With Amazon Route 53, the user is automatically directed to the elastic load balancing that is closest to the user. Multi-region deployment of Route 53 enables latency-based routing to the region and load balancing routing to the next availability zone. Amazon Route 53 DNS failover enables you to improve the availability of your application that runs on AWS by configuring a backup and failover scenarios for your applications. It also enables highly available multi-region architectures on AWS, and it requires a health check in order to monitor the health and performance of your web applications, web servers, and other resources. Each health check that you create can monitor the health of a specified resource, such as a web server, the status of other health checks, and the status of an Amazon CloudWatch alarm. Here you see how DNS failover works in a typical architecture multi-tier web application. Route 53 passes traffic to a load balancer, which then distributes the traffic to a fleet of EC2 instances. To ensure high availability, you can create two DNS records for the host www with a routing policy of failover. The first record is called the primary, and it points to the load balancer for your web application. The second record is the secondary, and it points to a static web page hosted in a specific Amazon S3 bucket. That bucket is configured as a website. Route 53 health checks and makes sure that the primary site is available. If the health check fails, a static splash page will be distributed. The static page alerts customers that you are restoring service. Thanks for watching. We'll see you in the next video. Hello and welcome. This video will cover Amazon CloudFront. One of the challenges of network communication is network performance. When you browse to a website, your request is routed through different networks. The origin server stores the original version of the data, which is commonly high density, like images, songs, or even videos. The distance between the customer and the original data server significantly affects performance in the playback and user experience. Also, network latency happens to be different depending on the geographic location of your users. For this reason, a content delivery network is an essential part of a smooth user experience. Amazon CloudFront is a fast content delivery service that securely delivers data to customers at high transfer speeds. It also provides a developer-friendly environment. CloudFront delivers files to users over a global network of edge locations. It is different from traditional content delivery solutions because you can take advantage of high-performance content delivery without negotiated contracts, high prices, or minimum fees. Like other AWS services, Amazon CloudFront is a self-service offering with pay-as-you-go pricing. Amazon CloudFront relies on Route 53's geolocation routing. Basically, a customer makes a request, Route 53 finds out where the customer is located in the world, and it responds with the IP address of the edge location closest to that customer. CloudFront then obtains the data from where it normally lives and copies it to the edge location. Then, the customer's user experience begins. As data becomes stale, it is removed from the cache at the edge location in order to make room for new content. You can define the expiration of data in the cache using a time-to-live number. This defines the amount of time in which the data cache will remain valid. Thanks for watching. We'll see you in the next video. It's now time to review the module and wrap up with a discussion of a practice certification exam question. In this video, you learn how to recognize the basics of networking, describe virtual networking in the cloud with Amazon VPC, design a basic VPC architecture, list the steps to build a VPC, identify security groups, create your own VPC, describe the fundamentals of Amazon Route 53, and explain the benefits of Amazon CloudFront as a content distribution network. Great work! Let's look at a sample certification question. Which AWS networking service enables a company to create a virtual network within AWS? The keywords to recognize are AWS networking service, which narrows the scope of AWS service offerings, and create a virtual network, which indicates what the service allows the customer to do. Let's look at the answer choices and rule them out based on the keywords we have highlighted. We can eliminate choice A because AWS config is not a networking service. We can also eliminate choices B and C. While Amazon Route 53 and AWS Direct Connect are both networking services, they are not what you will use to create a virtual network within AWS. As you have learned, Amazon Route 53 is a DNS web service, and AWS Direct Connect provides a dedicated private network connection between AWS and a customer's data center. The correct answer is D, Amazon VPC. Amazon VPC enables you to provision a logically isolated section of the AWS cloud where you can launch AWS resources in a virtual network that you define. Thanks for watching. We'll see you in the next video.
Welcome to Module 6, Compute. In this module, we will address compute services as an overview, Amazon EC2, Amazon EC2 cost optimization, container services, an introduction to AWS Lambda, an introduction to AWS Elastic Beanstalk. In addition to the topics covered in this module, there are several resources available to further your understanding of the AWS compute services, including a recorded EC2 demonstration and a hands-on lab where you practice launching EC2 instance from the AWS Management Console. You will also explore the advantages and disadvantages of running a database deployment on Amazon EC2 versus running it on Amazon Relational Database Service, RDS, as well as several activities where you will explore AWS Lambda and Elastic Beanstalk. Finally, there's a knowledge check that you will use to test your understanding of the key concepts that are covered in this module. After completing this module, you should be able to provide an overview of different AWS compute services in the cloud, demonstrate when to use Amazon Elastic Compute Cloud, Amazon EC2, identify the functionality in the EC2 console, perform basic functions in Amazon EC2 to build a virtual computing environment, identify Amazon EC2 cost optimization elements, demonstrate when to use AWS Elastic Beanstalk, demonstrate when to use AWS Lambda, And finally, identify how to run containerized applications in a cluster of managed servers. Let's get started. Welcome. This video will provide an overview of AWS Compute Services. AWS offers many compute services, which we cover in this module. Take a moment to review the compute services highlighted. Here's a brief summary of what each compute service offers. Amazon Elastic Compute Cloud, Amazon EC2, provides resizable virtual machines. Amazon EC2 Autoscaling supports application availability by allowing you to define conditions that will automatically launch or terminate EC2 instances. Amazon Elastic Container Registry, Amazon ECR, is used to store and retrieve Docker images. Amazon Elastic Container Service, Amazon ECS, is a container orchestration service that supports Docker. VMware Cloud on AWS enables you to provision a hybrid cloud without custom hardware. AWS Elastic Beanstalk provides a simple way to run and manage web applications. AWS Lambda is a serverless compute solution. You pay only for the compute time that you use. Amazon Elastic Kubernetes Service, Amazon EKS, enables you to run managed Kubernetes on AWS. Amazon Lightsail provides a simple-to-use service for building an application or a website. AWS Batch provides a tool for running batch jobs at any scale. AWS Fargate provides a way to run containers that reduce the need for you to manage servers or clusters. AWS Outposts provides a way to run select AWS services in your on-premises data center. AWS Serverless Application Repository provides a way to discover, deploy, and publish serverless applications. You can think of each AWS compute service as belonging to one of four broad categories defined as infrastructure as a service, compute that provides you with virtual machines, serverless computing, container-based computing, and lastly, platform as a service for web applications. In the first category, we have Amazon EC2, which provides virtual machines. Services in this category provide flexibility and leave many of the server management responsibilities to you. You choose the operating system, and you also choose the size and the resource capabilities of the servers that you launch. Amazon EC2 was one of the first AWS services, and it remains one of the most popular. In the second category, we have AWS Lambda, which is a zero administration compute platform. AWS Lambda enables you to run code without provisioning or managing servers. You only pay for the compute time that is consumed. Serverless computing is becoming more popular because it supports cloud-native architectures, which enable massive scalability at lower cost than running servers 24/7 to ensure that the same workloads can run. In the third category, we have container-based services, including Amazon Elastic Container Service, Amazon Elastic Kubernetes Service, AWS Fargate, and Amazon Elastic Container Registry. Containers are provisioned more quickly than virtual machines due to abstracting the operating system from the provisioning process. Container-based solutions continue to grow in popularity. Finally, in the fourth category, we have AWS Elastic Beanstalk, which is considered a platform as a service for web applications. AWS Elastic Beanstalk facilitates quick deployment by providing all the application services that you need. AWS manages the OS, the application server, and other infrastructure components so that you can focus on developing your application code. AWS offers many compute services as there are several different use cases. The optimal compute service or services that you will use depend on your use case. When selecting your compute service, you will want to consider the following questions. 1. What is your application design? 2. What are your usage patterns? And 3. Which configuration settings will you want to manage? Selecting the wrong compute solution for an architecture can lead to application performance, availability, or deployment issues. You can always launch a best guess design, or based on recommendations from the developers for an existing application, you can also use metrics and then collect computer-related metrics to reevaluate compute needs based on what the metrics tell you. A customer may start with one compute solution and decide to change the design based on usage patterns or changes in the application design entirely. Thanks for watching. We'll see you in the next video. Welcome. This is part 1 of the video series describing Amazon EC2. In part 1, we discuss AMIs and Amazon EC2 instance types. Running servers on premises is expensive. Servers must be purchased, data centers must be built, staffed, and maintained. Organizations must permanently provision enough hardware to handle peak workloads. After all the hardware is in place, server capacity often sits idle for significant portions of every day, which is wasteful. Amazon Elastic Compute Cloud is a different option. Amazon EC2 provides virtual machines where you can host the same applications you run on premises servers. It provides secure, resizable compute capacity in the cloud. Common uses for EC2 instances include application servers, web servers, database servers, other types of servers listed here, or even servers not listed here. Amazon EC2 provides virtual machines, or VMs, in the cloud. These VMs are referred to as EC2 instances. You have full administration control over the Windows or Linux operating system that runs on these instances. Most server operating systems are supported, including recent versions of Windows, Red Hat, SUSE, Ubuntu, and Amazon Linux. With Amazon EC2, you can launch any number of instances of any size into any availability zone, pretty much anywhere in the entire world, in a matter of minutes. Instances launch from Amazon Machine Images, or AMIs, which are effectively virtual machine templates. You can control traffic to and from these instances by using security groups. The first time you launch an Amazon EC2 instance, you will likely use the AWS Management Console Launch Instance Wizard. The Launch Instance Wizard simplifies the EC2 instance creation process. If you accept all the default settings, this allows you to skip most of the steps provided by the wizard. However, for most deployments, you'll want to modify the default settings so that the servers you launch are deployed in a way that match your specific application needs. Next, we will discuss the 9 key decisions that you must make when launching an EC2 instance. The first decision you make when using the Launch Instance Wizard is which Amazon Machine Image, or AMI, to launch the EC2 instance from. Think of an AMI as a template. The AMI contains a Windows or Linux operating system, and it will often have additional software pre-installed. You can use different AMIs to launch instances that will serve different purposes. For example, you can choose one AMI to launch an instance that will become a web server, and choose another AMI to deploy an instance that will host an application server. You can also launch multiple instances from a single AMI. When choosing an AMI from which to create your EC2 instance, there are 4 categories of AMIs available. The Quick Start category offers pre-built AMIs provisioned by AWS for launching instances. Many Linux and Windows Quick Start options are available for your use. The My AMIs category contains AMIs that you have created. I'll discuss how to create these in a moment. In the AWS Marketplace category, a catalog with thousands of software solutions built into AMIs are available for use. They can help you get started quickly for specific use cases. Finally, we have the Community AMIs category, where AMIs created by people all around the world are shared. These AMIs are not checked by AWS, so use them at your own risk. Avoid using them in any production or corporate environment. Let's take a look at how AMIs are created. Starting with step 1, you see that you can create an instance from a starter AMI, such as Quick Start, or you can create an instance from a virtual machine that you imported from your on-premises data center that you turned into an AMI. Regardless of which AMI you launched the instance from, you can then connect to the instance, which is labeled unmodified instance in the diagram here, and make some modifications to it. For example, you could run a script to update the operating system with important security patches, or you might install or upgrade software on it, such as Python, Java, or other libraries. The result in this is that you come up with a modified instance. In step 3, you can then capture the modified instance as a new AMI. When you create an AMI, Amazon EC2 stops the instance, creates a snapshot of the root volume, and registers the snapshot as an AMI. After an AMI is registered, the AMI can be used to launch new instances in the same AWS region. The new AMI can now be thought as a new starter AMI. Step 4 shows how you might want to also copy the AMI to other AWS regions so that EC2 instances can also be launched to those locations as well. After you choose the AMI for launching the instance, you must next choose the instance type. AWS EC2 provides a selection of instance types optimized for different use cases. Instance types reflect combinations of CPU, memory, storage, and networking capacity. The different instance types give you flexibility to choose the most appropriate mix of resources, such as memory, processing power, disk type, network performance capabilities, as they're needed for your applications. Instance type categories include general purpose, compute optimized, memory optimized, storage optimized, and accelerated computing instances. Each instance type category offers many instance types to choose from. When comparing EC2 instance types, you will notice that instance type names consist of several parts. For example, consider the T3.large instance type. T is the family name, which is then followed by a number. The number is known as the generation number of that instance type. So a T3 instance is the third generation of the T family. In general, instance types that are of higher generation are more powerful and provide better value for the price. The next part of the name indicates the size of the instance. As you can see in the example, instance's size chart, a T3.2x large has twice the processing power, or CPUs, and twice the memory as a T3x large. Instance types vary in several ways, including CPU type, CPU or core count, storage type, storage amount, memory amount, and network performance. The chart here shows the different instance categories and which instance type families and generation numbers fit into each category type. Consider a few of the instance types in more detail. T3 instances are general purpose instances that provide a baseline of CPU performance with the ability to burst above the baseline. Use cases for this type of instance include web applications, development environments, code repository, microservices, test and staging environments, and many more. C5 instances are optimized for compute-intensive workloads and deliver high performance at low price per compute ratio. Use cases include scientific modeling, batch processing, and ad serving, highly scalable multiplayer games, and video encoding. R5 instances are optimized for memory-intensive applications. Use cases include high-performance databases, data mining and data analysis, in-memory databases, real-time processes of unstructured big data, Apache Spark clusters, and other enterprise applications. In addition to considering the CPU, RAM, and storage needs of your workloads, it's also important to consider your network bandwidth requirements. Each instance type provides a documented network performance level. For example, an A1 medium instance will provide up to 10 gigabits per second, but a P3DN 24x large instance provides up to 100 gigabits per second. It is important to choose an instance type that supports your networking requirements. When you launch multiple EC2 instances, Amazon attempts to place them so that they are spread out across the underlying hardware and not all located on the same hardware. However, you can use placement groups to influence the placement of interdependent instances to meet the needs of your workload. For example, you might specify that 3 instances should all be deployed in the same availability zone to ensure lower network latency and higher network throughput between the instances. Many instance types also enable you to configure enhanced networking to get significantly higher packet per second performance, lower network jitter, and lower latencies. Thanks for watching. We'll see you in the next video. Welcome. This is part 2 of the video series describing Amazon EC2. In part 2, we discuss networking settings, attaching an IAM role, user data scripts, and storage options. After you have chosen an AMI and instance type, you must specify the network location where the EC2 instance will be deployed. The choice of region must be made before you start the launch instance wizard. Verify that you are in the correct region within the Amazon EC2 console before you choose launch instance. Within the region, you can specify to place the instance into any existing subnet, into any existing VPC. The wizard also provides a link to create a new VPC or to create a new subnet if wanted. In the example shown here, the user has indicated that the instance should be deployed into a specific public subnet inside a specific VPC. If you do not specify a VPC when launching an instance, the instance will be placed in the default VPC. When you launch an instance in a default VPC, AWS will assign it a public IP address by default. When you launch an instance into a non-default VPC, the subnet has an attribute that determines if instances launched into it receive a public IP. If you want to, you can override this setting for the instances as you are launching them. It's common to use EC2 instances to run an application that must make API calls to other AWS services. To support these use cases, AWS allows you to create and attach an IAM role to the EC2 instance. Without this feature, you might be tempted to place AWS credentials on EC2 instances so an application can use them to call another AWS service. However, you should never store AWS credentials on an EC2 instance. It's not secure. Instead, attach an IAM role to the EC2 instance. An instance profile is a container for an IAM role. If you use the AWS Management Console to create a role for Amazon EC2, the console automatically creates an instance profile and gives it the same name as the role. In the example, you see an IAM role is attached to an EC2 instance to grant permissions to an application that runs on that instance. The application must access a bucket in Amazon S3. You can attach an IAM role when you launch the instance, but you can also attach a role to an already running EC2 instance. When you create an EC2 instance, you have the option of passing user data to the instance. User data can automate the completion of installations and configurations at instance launch. For example, a user data script might patch and update the instance operating system, fetch and install software, license keys, or install additional software. In example, user data scripts you see is a simple 3-line Linux bash shell script. The first line indicates that the script should be run by the bash shell. The second line invokes the yum utility, which is commonly used in many Linux distributions to retrieve software from an online repository and install it. The command tells yum to update all installed packages to the latest versions. Line 3 indicates that the wget utility should be installed. Wget is a common utility for downloading files from the web. For a Windows instance, the user data script should be written in a format that is compatible with a command prompt window or batch commands, or with Windows PowerShell. When the EC2 instance is created, the user data script will run during the final phases of the boot process. By default, user data only runs the first time that an instance starts up. User data scripts can be used strategically to reduce the number of custom AMIs that you need to build and maintain. For example, instead of maintaining software installations and configurations in custom AMIs, consider maintaining separate user data scripts to handle those actions at instance launch. When you launch an EC2 instance, you can configure storage options. For example, you can configure the size of the root volume where the guest operating system, such as Windows or Linux, is installed. You can also attach additional storage volumes when you launch the instance. Some AMIs are configured to launch more than one storage volume by default to provide storage options that are separate from the root volume. Each volume that your instance will have, you can specify the size of the volumes and the volume type, and whether the storage will be retained if the instance is terminated. You can also specify if encryption should be used or not. Let's look at the storage options available. Amazon Elastic Block Store, or Amazon EBS, is an easy-to-use, high-performance, durable block storage service designed to be used with Amazon EC2. Amazon EBS offers different volume types so that you can balance price and performance. If you stop an EBS-backed instance and start it again, the data will still be there. Amazon EC2 Instant Store provides temporary block-level storage for your instance. This storage is located on hard disks physically attached to the host computer. Instant Store works well when you must temporarily store information that changes frequently, such as buffers and cache. It's important to know if the instances are stopped, either because of an error or a malfunction, that the data on the Instant Store will be deleted. The root volume must run on Amazon EBS or Instant Store. However, for other storage needs, some options include Amazon Elastic File System, which provides a scalable, managed elastic network file system, and Amazon S3, which is an object storage service that offers scalability, data availability, security, and performance. Here, you see two examples of how storage options could be configured for EC2 instances. The example for instance 1 shows that the root volume, which contains the OS and possibly other data, is stored on Amazon EBS. This instance also has 2 attached volumes. One volume is a 500 gigabyte Amazon EBS storage volume, and the other volume is an instance store volume. If this instance was